All right, hey everybody, welcome to Cassandra Lunch number 12. Today we are going to be talking about Cassandra and Kubernetes, and of course, if anything else comes up that you guys want to talk about today. Actually, I'm gonna change my screen to a different one that's in front of me, so I'm not looking at, here we go. And we should be good to go. All right. Yeah, so today we're going to be talking about Cassandra and Kubernetes. I believe it's a big thing in the community. I also think that it's a big thing out of the community. This is part of the Cassandra Lunch. Cassandra Lunch is something we do as in the open source Apache Cassandra and the DataStax Cassandra community, specifically in DC and Chicago, but anybody's welcome to join on Wednesdays at noon Eastern Standard Time or 11 Central. Our organizers are myself and Kui. Kui and I have been doing this in the DC and Chicago area for about a year, maybe a little bit longer. And the Cassandra Lunch, we just started up earlier this year due to COVID. Would love to have you help out. Helping out gets you connected to people. Good for your career. We're part of the Data Community DC, which has been an inclusive organization for a while, well before the protests earlier this year. So if you know somebody that, or if you are somebody that is in an underrepresented demographic in the technology community, would love to have you or your friend come and talk about data. There's a bunch of different groups as part of the Data Community DC. Check it out at datacommunitydc.org. Here we talk about DataStax and Cassandra and anything related to Cassandra, which these days includes things like Spark, Kafka, Flink. When we're talking about operations, it could be Terraform, Ansible. Today we're going to talk a little bit about Kubernetes. So anything that relates to the design, build, and operations of platforms that have Cassandra or something like Cassandra in the middle of it. Normally, if there are some new people, we ask them for introductions. We're going to skip over that today. Group rules: if you have a question, just ask it either in the chat or just, interrupt politely. DataStax is one of our partners and a not only to the community of Cassandra DC and Cassandra Chicago, but also a partner company of ours at Anant. And recently they've been doing a lot for the open source Cassandra community, which they had left a while ago, but they're back in full swing. GW is a big sponsor of ours, specifically their business analytics group. They give us great venue. Hopefully they'll continue doing that after COVID is not as rampant. We have partners in Chicago and in DC. Looking for more partners. Right now, we just need folks to come either give us a venue when COVID is done, which I don't think it will be for a while, but maybe to sponsor some workshops. So we have institutional or organizational sponsors like Booz Allen, AOL. These folks have been funding us at a higher level, making sure that if, let's say, one of the 8 different groups has a shortfall in funding, the organization is then able to step in and pay for things like Meetup or pizza. Any announcements from anybody in the group? I think Arpan, you have a talk coming up today.
Yeah, we'll be giving a webinar on Presto and Cassandra. It'll just be a quick little intro about Presto, how to connect it with Cassandra, and then a demo that we've already set up in a notebook. So you can just download that right away. So we'll be using Presto from Presto DB. Presto CLI, DataStax Enterprise for running Cassandra, and then DataStax Studio for running the notebook for which we'll be using for the demo. But essentially what the demo will encompass is creating a key space, connecting it with Presto, running queries, seeing if we can run those queries in Presto as well, and then try running SQL join queries through CQL, which you can't do. And we'll be able to do that then in Presto, and we can show you what a simple example of the powerful capabilities you could do with Presto and connecting NoSQL, SQL, relational databases, big three data stores, and yeah.
Cool. Hey, Kui, you gotta do something about search engine positioning. I wasn't able to find this. We also should put this on the Meetup calendar. I'm gonna share this with the Apache Software Foundation Slack, which, by the way, if you guys are not a part of, a great little community of committers, developers. So, for example, I'll put this in the Meetup events calendar. And then I don't know, well, I don't think Presto is part of Apache Software Foundation, so I can't really put it in there.
Yeah, it has its own Presto Foundation.
Facebook Foundation? Yeah.
No, it's Presto. So some of the guys who worked on Presto DB, when they shifted off and made the fork for Presto SQL, they also created the Presto Foundation.
Gotcha. Okay. Well, to each their own. Looking forward to it. Thank you. Anyone else have something coming up related to Cassandra?
I've got a webinar tomorrow as well on testing your machine learning models.
Cool.
Specifically, we're going to be talking about the statistical measures that you use to tell how well your model works.
Mm-hmm.
And it's actually going to be split into parts, where the next part is we're talking about validation and how you use those measures in sequence over all of your data to get a better idea of what your model's looking like.
Gotcha. All right. Well, I will be on the lookout for that because I can't find it on Eventbrite. Oh yeah, here it is. Perfect. It's on our website. Who knew? Cool. Very cool. And I will put this also in the Meetups group here. Let me share this on the chat so that you guys, at least Ryan will have it also. Great. Thank you, guys. As a weekly thing, of course, we do these calls. DataStax is holding weekly workshops. I think they're in week 5 of an 8-week in-depth, hands-on workshop series where there's a session where you go through and you watch people, and then you have homework and you get to build upon what you're working on. All right. With that, we're good to go on our topic for today, Kubernetes. Before I start, has anybody here used Kubernetes at all? Okay. Well, okay, that means I'm going to start a little bit about what Kubernetes is, and then we'll go into Kubernetes with Cassandra. What about Docker? You can just raise your hand on the participants panel. Looks like pretty much everybody's used Docker. Okay. All right. Well, Kubernetes and Docker, they work together. They don't have to work together, but just a little bit of a history of Kubernetes before we get into Cassandra and Kubernetes. So the general story goes that Google was working on container technology for a very, very long time. And they were internally, they were calling it, I think it was called Let Me Containerize This. or something like that. Let me see if I can find it. Yeah, I can't find it, but that technology was used to run Google itself. And over the last 5 or 6 years, different container technologies have been making it out to the forefront. Most people don't know this, but Mesos was kind of the granddaddy earlier. Even before that, there were other Linux jail solutions. But when Docker came out, Docker really made it popular to containerize applications. And everybody knows that. Why? Because Docker basically said, this is the Docker file standard, and it was easier than the other standards. And so everybody went off and started using containers. Well, the issue that everybody was running into was, oh, okay, I have one computer and I can run these containers manually. Then the next thing that I want to do is I want to run multiple containers. So Docker came up with something called Docker Compose. And Docker Compose basically tells tells the server what everybody wants as one service. This is a very, very old picture, right? Initially, when you were to run Docker, you had to put in the command line, this is the image that I want. This is the build context and all this stuff. Well, with Docker Compose, essentially in one file, you could say, I want to have a web server, I want to have a database server, and I want these things to be connected. And I want to have a network with these characteristics. And Docker Compose works really well in one computer. Right? You can have one big computer and you can have like 50 different things that Docker Compose is doing. It even has a scaling function to scale containers. It's pretty useful. I like it a lot. We use it a lot at work. But then the next thing, that next challenge that people started to face was, okay, well, I have these things running on one computer. What if I want to run it on multiple computers? Well, it started a race, which I think at this point has pretty much been won by Kubernetes. But there were 3 main players, or main players as in what people actually knew about. One was Docker Swarm, which Docker had come up with. Another one was Kubernetes and is Kubernetes. And yet another one was Mesosphere, or now it's just called DCOS. DCOS. This is open source, and it's built with Mesos, which is an internal, which is a very native technology for containerization, but they realized very quickly that people wanted to use Docker, right? So they started to make this thing called DCOS. And over time, what I've seen, and by the way, these were not the only ones. There was Pivotal Container Factory, IBM had their thing, Red Hat had their thing. Another one was called Rancher Labs, right? They had their thing, right? And over time, in the last like 3 years, every one of them just converged on Kubernetes. Rancher Labs is a distribution of Kubernetes. Docker Swarm, basically the enterprise edition, by the way, when you install Docker Toolbox or whatever on a computer, it comes with Kubernetes. It comes with a mini cube. They use Kubernetes and they support Kubernetes. Amazon Container Service, Amazon's Kubernetes service, they call it EKS, Elastic Kubernetes Service. That was out for a while. Azure was starting to do things with Kubernetes where they were offering, you can use Docker Swarm, or you can use DCOS, or you can use Kubernetes. Well, now basically they use Kubernetes, right? It's won the battle. So Kubernetes is king in terms of Docker containerization. That was clickbait, guys. But what does Docker have to do with Kubernetes? Well, Kubernetes is using the Open Container Institute's OCI kind of standard. Docker, when it makes an image, makes it using that standard. You don't have to use Docker to deploy containers on Kubernetes. You can make a container using other technologies. It just so happens that most people use Docker, right? So I think like 80% of the time, people are going to use Docker images is a foregone conclusion. Like you're definitely using it for the most part. Why wouldn't you use it? Very specialized cases. Some people that have had their containers built on other systems, they would use it. Kubernetes, what is it? Well, it's a cluster. There's a master, and you basically have these resources available to you, and the resources have disks on them, they have memory on them, they have network on them. And what you do when you use Kubernetes is you say, these are the other players that were there. In Kubernetes, what you do is you specify, I want this disk to be available here, I want the memory for this to be here, and I want to make a pod. And a pod is kind of like a Docker Compose, meaning I want these applications to sit together. And I want these pods to go onto these machines. So when pods scale, one pod will have all the things it needs, and they'll make another pod on another machine. So you can keep adding computers to your Kubernetes cluster, and the pods will continue to scale. And if you are using something like Amazon, Google Compute, right? All you say is, I want more machines. I want to scale up my pods. I want more machines. I want to scale up my pods, and they'll just do it. Amazon came up with something called Fargate for Kubernetes. So AWS Fargate was initially for containers only, where you would like give one container, like a Docker image, and it would automatically scale it, like elastically. You don't even have to worry about servers. It's even easier than EKS, right? But now it works with Kubernetes service. So what you do is you define your application, right? Earlier, you had to build your container image, define and deploy instances, provision, memory, blah, 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 right? With Fargate, you're just like, build a container image, give the requirements, and it scales. So Kubernetes is basically made it in the rockstar realm of, if the clouds are basically running a service in your name, it means that you've made it, right? Like MySQL managed databases are everywhere. Who knew, right? Because MySQL is a very popular product. Now every cloud has a Kubernetes. Okay, we've talked enough about Kubernetes. Basically, what does Kubernetes do? It makes container orchestration easier, and it is now the de facto gold standard for doing that. Like doing it any other way is going against the grain. All right, we got that. Now, what does that have to do with Cassandra? Well, Cassandra, because it was built to scale, scales linearly. So every time there's more traffic or more data, we just add machines, and it scales like that. Normally, we would do that with virtual machines or with actual physical hardware. Because Cassandra is itself a cloud, it's like an underlying storage engine for many, many applications. It's like a microservice orchestrated system just to store data. That's all it does. So it scales. When people were starting to use Kubernetes with Cassandra, the challenge was Cassandra already has its own partitioner load balancer. In Kubernetes, you have to say, here's a service, here's a load balancer for the service. When you have these pods, the load balancer will spread the traffic. Well, if you add Cassandra to Kubernetes, you basically have to have a service per pod, and you really don't scale your pod because your pod needs one instance of Cassandra. Cassandra, it'll automatically scale as you add new pods. There's all these little issues with doing Cassandra and Kubernetes, which prevented people from really making it popular. Only the biggest companies in the world were using it. Well, other companies did come up with operators to make Kubernetes easier to use. So if you don't have an operator, you can define a very complex architecture in Kubernetes with just base images. I want this Cassandra thing, I want to use these configurations, I want this Cassandra thing to use this configuration, and this is the network I want for this data center, and this is the network I mean, you can do all of that, right? But a Kubernetes operator, what that does is you just give it at the high level. I want a cluster, I want this rack, and I want 3 machines in it. And I want another rack with 3 machines in it. I want another data center with rack 3 and 4 with 3 machines in each. And because an operator, well, there's different ways to make an operator, but essentially, when you make an operator, you make this custom resource definition for Kubernetes, and you say, I want to make this domain-specific language just for the Cassandra operator, and then you write code to implement that, to work with the Kubernetes API, right? So when you see cluster with a data center with the rack, the operator would go out and then interpret that, and it would say, oh, that means that I need to configure these machines using this rack in this data center, and I need to make these machines come up in this little network here. So writing an operator is no easy task. In fact, there is a there are many different Kubernetes operators. DataStax has one. InstaCluster has one. That was one of the earlier ones. Sky UK and Orange Telecom. And what this one is the newest one, right? When DataStax came out with their Cassandra Kubernetes operator, it coincided with the release of their Astra product. So when you go to DataStax's, astra.datastax.com, that is running on the same Kubernetes operator. And it was the kind of the first bet from from DataStax to say, hey, you can use this operator because we can use this operator. Up until then, all of these other operators were not like production grade. And I think even the Cassandra one, they say that it's like, be careful with it. This is alpha, right? What is this? Alpha. Where is this? Okay, it's not building. Is it alpha or beta? Alpha, right? So let's see what DataStax is about theirs. Hey, it's beta, so it's at least one forward. Actually, no, I think I misread it. No, it is. Yeah, it is. It is beta, so it is a little bit more robust than the other operators. But what an operator does is exactly what I was saying. You say, I want a cluster. I want this Cassandra, this version of Cassandra. All right. I want 3 nodes in there. Okay. And you tell it what type of storage. So server storage means that it just uses that same machine, but you can also use storage from like Google Compute. Has their, they have a different way to do a persistent volume basically. But you don't have to be a Kubernetes like a master to make your cluster. If you, so here's one example of, in the config have these things, but this is the whole thing. When you say apply this to your Kubernetes cluster, it'll make a 3-node cluster. If you didn't have this, I know I have I have a few here. If I go older, The older ones definitely, there we go. I think this one, oh yeah. So this actually kind of like goes through and says, okay, you have to have a stateful set. After you have a stateful set, then you can have it work. So in this case, what we're doing is we're just starting up Cassandra as an image, just as a Docker container, and having 3 replicas. But it doesn't do the configuration, right? There's a lot of other work that is not done here. Let me see if I can find a different example of the, here we go. I think this one, yeah. So in this one, again, you had to create your, let's see what this looks like. Create the service, okay. Then we went to use create. So you have to create local volumes. You have to create a stateful set. Valid. I mean, just to get a 3-node cluster, right? You have to go through all of these steps, and that's what the operator does. It makes the human operations. It automates them. Right now, the Cassandra community is discussing there we go. It is discussing the operator. There's these 4, as I mentioned, and they're discussing it. And then just last Friday, after some discussion, they open sourced the first commit of the operator. And it's, as you can see, it's forked from the DataStax Cassandra operator. And you can see, like, the moment it was forked, over the last 5 or 6 days, people are making commits at DataStax. But that one's also open source. But the difference that's happening is this is a community effort. This is Cassandra community with people from Instacluster, from Sky, from Orange Telecom, even I think there was a guy from Alessandra who's written their own operator. And they are working together to identify the best way to combine their knowledge, right? And that begins with creating a syntax. So in Kubernetes, you can use something called a CRD, as I mentioned earlier. It doesn't matter what you built your operator in. Eventually, you have to say, this is what my YAML file will look like, right? What is the language? So in order to be able to do this, you have to define these as a custom resource definition. So right now, the community is discussing and trying to agree on a CRD that everybody can work with. The design proposals, which I was showing earlier, they contribute different versions. So for example, this is coming from, I believe this is coming from the Instacluster version. And let's see where this is. I think this is coming from either Sky or Orange. And then here's another one. I think this one is, yeah. But this is where the community is today. It doesn't mean that we can't go out and use the DataStax operator. I think what's going to happen is all of the stuff that everybody's contributing to will eventually be the standard Apache Cassandra Kubernetes operator. And maybe just like how DataStax takes stuff and that they work on and they commit it back, hopefully they'll continue to improve. And since this is an open project, if the community wants to use the knowledge from DataStax, they can do that too. So come here, right? So people are continuing to work on the Cassandra operator. So that's Cassandra and Kubernetes. I know that was like 15 to 20 minutes of just brain dump. But does anybody have a question about Kubernetes or Cassandra? All right. Well, I think next time I'll do is I'll open up the GKE, or even on the local Docker containers, Docker service. I can run it on Minikube to show you how easy it is. Yeah, looks like a very promising project. Oh, one thing I forgot. The reason why Kubernetes Cassandra is converging is also because Cassandra 4.0, if you remember from our last talk, it streams data faster. What that means is when a cluster expands, data can stream fast. When it contracts, data can stream fast. That's what gives Cassandra the resiliency. When you remove a node, it like heals itself and replicates the data to the right machines. When you expand it, it determines where to move the data to thin out the data so it can scale. Previously, when you were doing Cassandra, you were doing it on a virtual machine. You don't want to put, let's say, more than 2 terabytes of data in it. Now with containers, you can have 50 gigabyte containers or even like a 100 gigabyte container, and just continue expanding it. And when it contracts, it quickly contracts. And gives people the ability to scale up and down their Cassandra clusters, similar to the type of services like Dynamo promise, right? Being able to expand when you need it and then contract when you need it. All right. That's all I got for today. And if there aren't any questions, we will, oh, looks like there's a question. Why use Kubernetes with Cassandra? So I think the main, I actually like running Cassandra on an actual machine. It gives me much more control. But what Kubernetes does is it provides one language to define in code the infrastructure for the whole platform, for databases, for queues, for AP, for everything. It's just one layer across the board. And because Kubernetes is supported by all of these companies, it makes it easier to go from like one cloud to the next. So when you use Kubernetes and you build your platform on top of Kubernetes, you're designing it for infinite scale, ideally, because you don't need Kubernetes if you're not designing it for infinite scale. You can do stuff. You can do stuff with Docker Compose. In fact, even with Docker Compose, you can do really big things with Docker Compose. So you need Kubernetes these days to build software that scales. That is portable from one cloud to the next. Cassandra has always been a multi-cloud, hybrid cloud database. You can have nodes in one, you can have a data center in one data center in Azure, you can have another data center for the same cluster in AWS, and it'll always keep synchronized. And you can do that with Kafka as well, you can do that with Spark as well. But when it comes to other applications, you have to build things like Kubernetes to scale and distribute the traffic and so on. So if you can build something on one layer, here's my database, here's my queue, here's my distributed computing, here are my API layers, here's all of the authentication. You can even put an API gateway on top of Kubernetes. You can put your machine learning on top of Kubernetes. So if everything is working on Kubernetes, you have your whole data center that's portable. And portability means not only from like one cloud to the next, you could run the whole cluster of your platform on one computer. You know, given you have 256 gigs of RAM, every one of the containers that is running on production, you could have a scaled down version of that on your computer. Again, you could do that with Docker Compose, but Docker Compose won't, off the bat, you know, give you infinite scale. You have to do some more work on it. Any clarifying question to that, Ryan? Cool. Awesome. I think that's something to put on our backlog, is to do a demonstration of Kubernetes, not just bringing up a Cassandra cluster, but you know, Cassandra, Spark, and Kafka, and scale it on Google Cloud and then scale it on Azure, and basically shouldn't be much of a difference. I mean, the only thing that would be different is they have different storage engines for their data, but everything else should be the same. All right. All right, guys. I think we're good. I'm going to stop the recording and then we can call it a day. Thanks, guys. See you guys next time. All right. All right.